TIL that certain random number generators use internal thermometers for input, as the small fluctuations in CPU temperatures is extremely unpredictable. It's not so much that you can't predict generally what the temperature of the CPU might be, it's that the measurement is inherently vulnerable to random noise. Imagine you had a digital thermometer on the wall that read the temperature in 0.0001 degree increments. That last digit would be all over the place and wouldn't represent the temperature so much as the random thermal noise in the sensor. I work in embedded systems, and it's a real problem sometimes to get random numbers. An MP3 player's shuffle function needs to get random numbers from somewhere, and you can't just write a program that conjures them from nothing. They'll come out the same every single time. You need some external source of entropy. And if you don't have user inputs or a real-time clock to use, you have to have some piece of hardware that is vulnerable to noise. A lot of the time they will use the timing of input between button pushes on your keyboard too. They will use a decimal place so small such that it's impossible to replicate the number even if you tried. I had a computer science professor tell us in lecture that when they used to need random numbers, they would read the third or fourth digit of the wind speed in that moment. Pretty clever. For those wondering why such bizarre methods are chosen, for reasons beyond my understanding, computers can't actually pick random numbers as just a pure software thing on their own. This is how I make passwords. The last few words I hear, that's my password, plus symbols and stuff. That's why my password is always ER at L0$ER. I remember making my first RNG. After being disappointed, the RND function in VB was not, in fact, random at all. I grabbed every hard to predict input I could find, temp readings, the milliseconds of the time, milliseconds since boot, etc., and made some crazy equation out of them. Worked well enough. Random. Org uses atmospheric noise. I dunno. A basket of kittens, he mentioned at the end, would be an adorable way to secure the internet. I use an analog pin not connected to anything. It's not temp fluctuations. It's thermal noise. You remember older stereos had a detectable hiss when the tape/record/CD wasn't even on? It's not from the media. It's not RF noise being picked up by the wire. Some of it would get louder when you turn up the volume, but some is the same even if you turn the volume all the way to 0. It's the sound of noise from the components themselves. It's loosely describable as the sound of current flow across the resistors and/or transistors. It's a totally unpredictable random hiss of noise. More modern amps use a bunch of strategies to keep that way down. But, you put a DC current through a resistor and AC couple it to an amplifier, you will have random noise. They must just use the current mood state of my cat. At any given time you cannot predict if it's hungry, friendly, sleeping or pissed off. I'd love to hear from someone who knows about Zune's shuffle. I remember filling mine up with music day one, and the shuffle would always put the music in the same order but the starting song would be different. So like the shit would be like 7 8 9 10 1 2 3 4 5 6. The next time it would be 9 10 1 2 3 4 5 6 7 8. 1 year in I'd know the next song every single time on a blind shuffle. Understand, I simplified the song list. I had hundreds of sounds on said Zune. Is random number generating an imperfect science? To what degree do we know what the general outcome of truly randomly generated number would be? Obviously I know it wouldn't be random if we really knew, but also what I mean is in anything that isn't dictated by patterns considered random. Even if it appeared to generate certain numbers more than others. Or would perfect randomization over long periods of time be very equitable? Yep, I did this as part of a project in college, one of the many neat little tricks for making better numbers to generate. It would seem that small unpredictable fluctuations is exactly what you want for a random number generator. Was this hard to come up with? Seems like finding a source of noise for sufficient randomness isn't that hard, but either it really is or people just don't realize typical RNGs aren't that random. Oh hey. My PhD is in this kind of stuff. TL, DR, this is talking about entropy sources, and ideally you want an entropy source you understand fairly well, so you can test it's doing what it's supposed to be doing and assert a minimum entropy estimate. PokerStar's platform uses shooting an actual laser through a glass and monitoring the light spread to create RNG. There's a website that has a truly random number generator by using an old Radio Shack radio's intense static from atmospheric interference to seed its RNG. There's one website for random numbers that converts the waveform from a microphone placed outside in some random outdoor location. The wind and random noise is effective randomization, apparently. I used to work for a security specialist company that hosted computers in a decommissioned nuclear bunker. They were thinking of drilling a deep hole there and using the background radiation at the bottom as entropy. For non-nerdy folks, it's called a seed. Think of the seed that grows a random tree and the length of the randomly chosen branch multiplied by the leaves on it gives you your random number. Every equation processed uses the same algorithm, which doesn't make it random and can be easily reverse engineered and predictable, called pseudo-random. A good example of this is Michael Larson on a game show called Press Your Luck, https://youtube.b/bfom7k8a0pw. He learned the pattern at home recording numerous episodes and cheated the system. Most random number generators use actual random values from random inputs into those algorithms, like CPU frequencies, mouse input, fan noise level, etc. This is called entropy. Oh. One other way that they were able to make random number generators was using the values of the silicon in uninitialized areas of volatile memory. When volatile memory is booted, each chip, due to stupid tiny differences in the silicon of the memory or chip, has a different state that it reaches. From this you can get seemingly random seeds, or even identify a chip's manufacturing date/model based off of these differences, if it is logged somewhere. That is definitely an interesting. There's a lot of talk about thermal noise on an ADC, but I know there's also been cases of allowing a latch to settle out of metastability using the thermal noise of the latch, meaning you can get a logical 1 or 0 without the ADC, which is kinda cool. I cannot for the life of me find this paper though. It's also worth mentioning the thermal noise isn't strictly quantum in nature, so it might be preferable to use shot noise or another truly quantum process, but that isn't a luxury that a lot of embedded systems have. This is one way to do it, but it's not the most commonly used way. Usually, there's an algorithm that will output the same sequence of unrelated numbers, and you seed the algorithm with the current time. Time in 99% of computers is counted as the number of seconds since midnight January 1, 1970. It's not truly random, but it's close enough for most purposes that don't involve encryption. The other way is using a special device file on Linux called /dev/random. It collects random noise data from device drivers, mouse movements, and the like, and uses it to generate a stream of pseudo-random data. This is what most encryption libraries use to generate keys for encryption. Again, it's not truly 100% random, but it's close enough. Only if you're encrypting classified government or corporate documents do you need something like temperature or wind fluctuations. Obviously it depends on the audience, but within the military we were well aware that you could spray liquid nitrogen on the processor to get the RNG to generate a 0 and thus break the crypto. Can't you just use the time and pi? Based on exactly what time it is down to the millisecond and do some weird equation that adds the hour to the minute, subtracts the seconds and multiplies the milliseconds, to choose that number in pi.